Welcome and thank you for joining me. We're about to start lesson U2A6 where we will investigate the intersection of a line with a plane. Before we get started, we're going to go over the various cases of how a line can intersect a plane. So if possible, I have a piece of paper ready and a pencil, and try to envision together as we go through each and every case of how a line intersects a plane. Case number 1 is when the line gets through the plane. In this case, there will be one point of intersection. Case number 2 is when the line is parallel to the plane, which means that there will be no points of intersection. And case number 3 is when the line lies flat on the plane, which means that there will be an infinite a number of points of intersection. So we're going to take a look at 3 different examples so that we can connect the algebraic solutions with each case. So example number 1, we have to determine the point of intersection made between the line L with equation R equals 312 plus S negative 184 negative 8 and the plane pi with 4x plus 2y minus z minus 8 equals 0 as an equation. Now, remember that here we're given the vector equation of the line and here we're given the scalar equation of the plane. And we're going to say that if a line intersects the plane, that can be at any point of the line. So we're going to say that any point with coordinates x, y, z from this line can intersect the plane pi. And for this, we're going to start off with identifying the coordinates of any point on this plane, which will be, remember, x equals 3 plus 1s, y equals 1 plus negative 4s, and z equals 2 plus negative 8s. Now, if the coordinates of a point from this line satisfy the scalar equation of this plane, it means that there is a point of intersection. Now, how can we tell that the point will intersect or there will be a common point algebraically? So we're going to substitute the x, y, and z coordinates of this point, ordinary point on the line, and substitute it into the equation. And this is what we're about to see. So we have 4, and instead of x, we'll substitute 3 plus s, plus 2, instead of y, we'll substitute 1 minus 4s, minus z, which is 2 minus 8s, minus 8 equals 0. If it's possible to find an s value for this equation, then we'll say that it is possible to calculate the values of x, y, and z, which means that there will be a point of intersection. So let's solve the equation. We have 12 plus 4s plus 2 minus 8s minus 2 plus 8s minus 8 equals 0. So like terms, we have 4 plus 2 minus 8 negative 4 plus 1 s negative 3. And for the constants, we have 12 plus 2 14 minus 2 12 again, and minus 8 equals 4. So s would be equal to 4 over negative 3.